This FJ Cruiser's suspension is currently stock. It has both the anti-roll bars in the front and rear of the vehicle. I'm going to do a quick articulation test on this FJ Cruiser. I have a ramp under the left front tire. I also have a ramp under the right rear tire. So I'm going to back this up and just see if it can get all the way up on this ramp. Now these ramps I believe are 6 or 6.5 inches tall, not too much. Since the FJ Cruiser has an independent front suspension, I worry that it won't be able to get on top. This is the first FJ Cruiser I've had. Now I've had a bunch of Land Cruisers which had solid axle front and rear, and it could easily get on top. So we're just going to do this test. This FJ Cruiser was easily able to crawl up those ramps. This front tire is solidly on the ground, while this one's up here on the lift. Just for fun, I tested my Scion IQ and got 3.5 inches of the same articulation test, so about halfway up these ramps. While this is not a particularly difficult test, it still shows a considerable amount of articulation in stock form. This still has the stock sway bar, which is right here. That rear solid axle has plenty of articulation to compensate for the independent front suspension. Nevertheless, I'm probably going to remove that front sway bar just to give the front a little bit more articulation. Let's talk briefly about what a front sway bar actually does on an independent front suspension. So if this is your right front tire and this here is your left front tire, there is a bar that is connected between these two wheels. And what this bar does is it actually allows force to be applied to the opposite side when there's a force applied to the near side. So when this wheel goes up, this other wheel here will actually go up as well. And there's a torsion bar right here. Now this part of the bar is attached to the frame of the vehicle. And so you can see when you raise this wheel up, this will act almost like a spring and cause this other wheel to start to pivot up as well. It's not going to be 100% of the difference, but that spring rate will determine how much this other wheel will raise. This is my horrible drawing of a car. But imagine you're watching a car go away from you and he's taking a hard right-hand turn. What's going to happen is this car is going to want to pivot and lean to the left around that corner, which in turn is going to compress this wheel here. Well, because there's this torsion bar or sway bar between them, it will also try to push this wheel up, which in turn means that instead of this leaning quite as much as it's going to lean significantly less based on how much that torsion bar pushes this other wheel up. This is great for handling on the road because you want your car to not lean as it goes through corners. The problem arises when you decide to go off-road. Let's assume this is a big rock, same view of the vehicle. You can see that if your wheels and tires remain on the same plane, your car is going to lean considerably to the right. This can be a problem for potentially rolling over, as well as having a difficult time going off-road, clearing obstacles. Off-road, what you really want to have happen is this. You go over that same rock, and this wheel and tire tuck way up into the car, while as your other tire and wheel droop all the way down, make solid contact with the ground, and therefore can continue progressing down the road. So in a very real sense, you have very conflicting objectives going off-road versus on-road. Sway bar works great on-road, but off-road, it can be a detriment. I do not recommend driving without your front sway bar in. Nevertheless, if you do remove it, make sure it's for off-road use only. To remove the front sway bar or anti-roll bar, first jack up the car and remove the wheels. Shock one of your rear wheels. Start by breaking free all the nuts on the wheels. You'll need a 21mm socket. Here's a diagram showing all the jacking points and support positions. The recommended jack point is right here on this cross member. Don't use a book, use a piece of wood, as the pages can slip in between. Once both wheels are off the ground, place your jack stands. The vehicle jacked up is a little bit too tall for my jack stands for this position here, so I'm going to put them right here underneath this cross member. Once you have 2 jack stands in place, slowly lower the car onto the jack stand. Leave your jack, just in case, for a third point of contact. Remove your lug nuts and your front wheels. Spray down all the fasteners that you're going to remove with some sort of liquid wrench or blaster. That'll loosen those up, get some of the rust off before we start cranking on these. With a 17mm socket, remove this nut here to remove the end link. I'm gonna have to use a little persuasion on this nut because this side of it turns on this little ball joint. So we'll see if this works. Nope. I put a set of vice grips on the end of this. Now we'll try again. That seemed to have worked. Do the same on the other side. This may slam up here, we'll see. Whenever working under a car or on a car, always use safety glasses, especially if you're going to use power tools. With a 14mm socket, remove the 2 screws here holding this bushing, and same on the other side. Before taking off the last screw, make sure you have something bracing the sway bar so it doesn't come and fall on your head. Right now I'm just holding it up with my knee. The screws that held the bushing on are a little corroded. I'm going to put a little anti-seize and put them back in the holes just to make sure that those stay clear. That's it. That's how you remove the sway bar on this FJ Cruiser. That will give just a little bit more articulation to the front of this vehicle to match the rear. With this sway bar off, we finally have a true independent suspension on this FJ Cruiser.